Example number 6. F of x is equal to 4x times log base e of negative x. So f prime of x is equal to 4, let's just keep that in the front, times x times the derivative of the natural log of negative x. So using the chain rule, we get 1 over negative x times the derivative of negative x, which is negative 1, plus natural log of negative x times the derivative of x, which is just 1. Simplifying, the first term becomes just 1 plus natural log of negative x. All right. Okay. Derivative of this big thing is the first function, x squared plus 2x plus 2 times the derivative of e to the negative x, which is just e to the negative x multiplied by the derivative of negative x, right, by chain rule, which is negative 1, plus e to the negative x times the derivative of the first function, which is 2x plus 2. Now let's simplify. We can pull out an e to the negative x in front, and everything in this first set of brackets gets a negative sign because of the negative 1. And then to that we add 2x and 2. So conveniently we have negative 2x plus 2x, which cancel, and also a negative 2 and a positive 2, which also cancel, leaving us with negative x squared times e to the negative x. So that's simplified very nicely. Next example. So we're given f of x without being told explicitly what that function looks like. But we can still figure out how to differentiate this expression using the product rule. So we have not touched the quotient rule yet. So let's first rewrite this using a negative index so we can apply the product rule. E to the x times f of x raised to the power of negative 1. Okay, and I've written it like this with the square brackets and the negative 1 on the right, as opposed to this, right, which is what we use to denote inverse functions. Okay, so now let's just apply the product rule. First function, e to the x multiplied by the derivative of our second function. All right, let's use power rule combined with the chain rule. So the exponent comes down, negative 1 times f of x raised to the power of negative 1 minus 1, which is negative 2. And then chain rule part is f prime of x. Okay, so I'm going to put brackets here. It's a product. And now plus the second function, which is f of x to the power of negative 1 multiplied by the derivative of our first function, e to the x, which is just e to the x. Let's simplify this a little bit. So e to the x, it's a common factor. Let's bring that in the front and use brackets. And now let's put our negative indices in the denominator, so turn them into positive indices. So over here we have f of x to the power of 2. And on top, we have a negative f prime of x. And then plus 1 over f of x. Okay. Now, to obtain a common denominator, let's multiply this expression on the right by f of x over f of x. Okay, and this will allow us to write our function as e to the x times f of x minus f prime of x all over f of x squared. All right, so even though it might look strange not to have a function explicitly written, it's still possible to just use the principles of, or use the rules of differentiation, product rule and chain rule, if applicable, and obtain an expression in terms of f of x and f prime of x. Next example. Okay, remembering that the derivative of cosine is sine, let's write that the derivative of our function is equal to, so constant stays in the front, doesn't get touched. Our first function, x, times the derivative of cosine of x, which is negative sine of x. I'll put the negative sign in the front, plus cosine of x times the derivative of x, which is 1. I don't see a need to simplify this expression any further, so I'll leave it like that. Okay, final example. F prime of x is equal to, okay, we'll leave the 4 in the front, x squared times the derivative of e to the power of sine x. So by the chain rule, we just write e to the sine x and then multiply that by the derivative of sine of x, which is cosine x, plus e to the power of sine x times the derivative of x squared, which is just 2x. Okay, we can clean this up a bit. So we have, we can take out x as a common factor, as well as e to the power of sine x, leaving us with x cosine x plus 2. Great, thanks for watching.